HVAC systems are responsible for the regulation of heat, airflow, ventilation, and air conditioning of an entire building. You won't see the machines when you enter the building, but will most certainly feel the effects of a comfortable and well-ventilated workplace. Today, sir, I, Zainal, and my teammate Salain Diaz will dissect the HVAC system of an industrial building. So HVAC stands for heating, ventilation, and air conditioning. HVAC refers to the different systems used for moving air between indoor and outdoor areas, along with heating and cooling both residential and commercial buildings. So warehouse in an industrial building used for storage and transportation of goods. It is typically a single-story building with at least 60 feet high ceiling due to the necessary racking and storage systems under its roof. So according to Anish Kadyan, HVAC is critical for the warehouses because a lot of products are sensitive to temperature or humidity and dust, and no consumer likes to get damaged or defective products. So some of the unique features of an warehouse HVAC system. First is warehouse HVAC systems are simpler and require basic and expensive heat, but as any structure would, warehouses bring with its own set of design challenges. Second, some warehouses require precision temperature and humidity control for product-sensitive storage. Third, while most of the space in a warehouse is dedicated to the storage racks, there are other functional aspects that a warehouse must cover. Some warehouses need to maintain low temperature for products like wine, requiring cold storage, while humidity can be an issue for others. So for our research, we chose to dissect the HVAC system of an industrial building type, which is a warehouse. So specifically, the Wine Warehouse, South California, located at Los Angeles, California. So this is the picture of inside the warehouse. The Wine Warehouse, California utilizes a centralized system as the warehouse needs a large cooling capacity to maintain a certain temperature for beverages. As the name implies, a centralized system is a single system that supplies the HVAC needs of the building. The centralized is generally located in a single zone. So these systems consolidate units and typically use water as a cooling medium and use of extensive ductwork for air distribution. Some of the advantages of having a centralized HVAC system are having a greater load management potential and better control of the system, while its disadvantage is more sophisticated to operate and maintain, hence it is expensive to install. So how does a chiller, AHU, and cooling tower works together? So the HVAC system in the wine warehouse mainly utilizes a system of chillers. Since the warehouse is concerned with wine, craft beers, and artisan spirit inventory, a certain temperature should be kept to keep the quality of the drinks. Thus, a system of chillers is being utilized in the warehouse. This system has the following components that work together to keep the warehouse's temperature low. So, a chiller, a cooling tower, a pump, and an air handling unit. The wine warehouse utilizes a system of chillers for their HVAC system to keep the temperature needed for the preservation of the beverages, especially during the summer where there is an increase of heat gain. So the building needs a system to keep the temperature for the warehouse. In the illustration, it is a very typical setup where there is a chiller along with the distribution pumps and the air handling units and the cooling tower which is up on the roof. So now let's proceed to the chiller system. Chiller system. So the function of an industrial chiller is to move one location, usually process, equipment, or product, to another location, usually the outside air of the manufacturing facility. So chillers are typically located at the basement or on the roof. So rooftop chillers tend to be air-cooled, whereas basement chillers tend to be water-cooled. It is used to cool products and machinery, knowing that a wine warehouse stores wine and this wine needs to be preserved, thus this chiller system is very important in a warehouse. So there are two types of a chiller system, a water-cooled chiller system and an air-cooled chiller system. So the difference between the two is that an air-cooled chiller system is usually located externally, either up on the roof or at the ground level, while it does not use cooling towers and they dump their heat into the ambient air, while water-cooled chiller system is typically located in the basement or lowest floor of a building. It needs a cooling tower to reject heat from the building. It produces chilled water and pushes this around the air handling unit and fan coil units. Both types generate the same function, which then generate cold water for the air conditioning by removing the unwanted heat away from the building. So these are the different components of a chiller system. So this is the compressor. So it is a prime mover. It creates a pressure difference to move refrigerant around the system. So this is the condenser. The condenser is a bundle of horizontal pipes which contains the hot refrigerant. Condenser fans. This is a condenser fan. So it sucks air across the condenser coils entering from the sides and then forces air out the top of the unit upwards into the ambient atmosphere. Its purpose is to transfer heat from the refrigerant system into outer area, which helps to avoid overheating of the compressor. So this is the expansion valve. Expansion valve, its purpose is to expand the refrigerant before it enters the evaporator, reducing its pressure and increasing its volume, which allow it to pick up the unwanted heat in the evaporator. Evaporator. So it is located between the expansion valve and the compressor. So the purpose of this is to collect the unwanted heat from the building. So the heat will be transferred to the refrigerant, then to the cooling tower, and it will be rejected. So this is the power unit. So the purpose of the power unit is to control the flow of electrical power to the chiller. So inside inside of a power unit there are controls. So the control unit will generate alarms for the engineering teams and safely shut the system down to prevent damage to the unit. Usually, controls have BMS connections for remote control and monitoring. So this is a water box. So water boxes are mounted to the evaporators and also the condensers of water-cooled chillers. So the purpose of the water box is to direct flow as well as to segregate the entrance and exit. So water boxes are only found in a water-cooled chillers. So this is an illustration of how does a chiller system works. So this is the evaporator. So this is the compressor. These are the controls and the power unit. This is the compressor. This is the compressor. This is the evaporator, expansion valve, and condenser. So how does a chiller system works? So the chiller is the producer of the chilled water in the system. It has two main cylinders, the evaporator and the condenser. It's collected and sent to the cooling towers. The evaporator is to the chilled side where it's insulated to keep the cool inside. A compressor is placed on top of the evaporator together with the power supply and the control to the system. The illustration below is a centrifugal chiller used by the wine warehouse. The chilled water leaves the evaporator and it is pulled out by the pump. So next, air handling unit. So an air handling unit is usually a large metal box containing different components needed for proper functioning of HVAC system. It works alongside the chilling and cooling towers in order to circulate and maintain the air through the process of heating, ventilation, and cooling or air conditioning. So this is a air handling unit. So there are 6 components for an air handling unit. First, housing. The housing contains all the other components of an AHU and is usually made of metal, but some are painted to prevent corrosion. Second, fan. Centrifugal fan is used to circulate the air to the various parts of the sections in the building. So next, cooling coil. So a cooling coil is used to cool and dehumidify, which means removes the moisture from the air. So aluminum fins and copper tubes are used in the design of the coils. Filters. So filters are to remove the particles and contaminants of various sizes from the air. So the type of filter being used will very much depend on the application of the system. Humidifier. So during cold seasons, the humidity level of the air can be low, hence causing discomfort to the occupants. The humidity of the air is increased by using humidifiers. Mixing box. The place where outside air and the return air are mixed to provide a correct proportion of air to be distributed to the space that is to be conditioned. So how does an AHU works? So the air handling units are connected to the ductwork, which provides a defined route for the air to travel around the building. So basically, an AHU uses a fan to suck in fresh ambient outside air, which will then pass through some filters to remove any dust and dirt. It will then pass through the cooling and heating coil. Heat exchangers, which as discussed, are typically fed from the cooling tower above. Once the air has passed through the coils, it will be pushed out around the building. So to put it simply, there is a release of cold air at around 6 degrees Celsius from the chiller to air handling units. Then there is a collection of warm air at around 12 degrees Celsius from AHU going down to the chiller up to the cooling tower to be released from the build. So my teammate will discuss the cooling tower and pumps used in an industrial building.
Cooling towers. Cooling towers is usually located up in the roof, and it is the final destination for unwanted heat inside the building. Here are the components of the cooling tower system. We can see the parts, which are the fan, drive belt, drive motor, spray nozzles, fill packaging, make-up water, overflow, drain, float veil, basin, condenser water outlet, filter, condenser water inlet, and drift eliminator. You can also see the illustration of cooling tower system and its components. So how does a cooling tower works? Cooling tower system has a warm water and condenser from the building where it will pass through the spray nozzles. As the warm water goes down to the basin, the water starts to lose its heat and turns to a cold water. The cooler condenser pushes the water out of the machine and releases it inside the building. Another thing is that a cool air is sucked in by machine where it goes up through the drift eliminator. As the cool air passes through the drift eliminator, it starts to lose its humidity, then it turns into a warm air. The warm air then be pushed out from the machine out of the building. Next is the pump. A pump is a machine used to raise liquids from a low point to a high point. In a centrifugal pump, liquid enters the center or eye of the impeller and flows gradually out between the vanes, its velocity being increased by the impeller rotation. Here is the components of the pump. So how does pump works? A centrifugal pump moves water known as condenser water between the chiller in the basement and the cooling tower up on the roof. The chiller adds heat to the condenser water, and the cooling water above cools it down by rejecting this into the atmosphere. The heat it rejects is all the unwanted heat from the building caused by the people, the sunlight, the lighting, and etc. It must also reject the heat generated by the compressor of the chiller. The condenser water leaves the condenser of the chiller at around 32 degrees, as shown in the illustration, and the pump sends this up the cooling tower. The system has been designed so that the condenser water leaving in the cooling tower and re-entering the chiller condenser below must be around 27 degrees in order for them to be able to pick up enough heat for its next cycle. Next, the difficulties in temperature regulation in an industrial building. First is heat or cold containment. It is one of the biggest difficulties in controlling the temperature inside a warehouse or an industrial building because of the heat and cold that goes in and out of the building. Because of the large openings like doors and windows, common leak points can be seen inside the building compared to the smaller places or buildings. Next is airflow. Air inside the building tends to settle because of the large and enclosed space. Even powerful HVAC systems that works on full power are not enough in this situation. Stagnant air creates many problems and it creates complication in the temperature control. Next is low air velocity. Air velocity affects the comfort of every people inside the building, and it is one of the factor of thermal comfort. Discomfort may be felt in the air velocity is not according to the comfortable limit. Low air velocity, especially during summer, means it has a lack of ventilation, and it may cause spreading of diseases and allergens to the people inside the building, and also may cause damages to the products or goods that are stored inside. High level of humidity. It creates uneasiness and uncomfortable feeling to the people or employees inside the building. May also get worse, especially during humid or rainy days, and also may cause health problems and would be hard for them to breathe. According to the thermal comfort standard, 40% to 70% is the range to the relative humidity, and if it lies in those range, then it is comfortable. Air temperature. Temperature either too high or too low may cause discomfort to the employees. It may also negatively affect their productivity and efficiency. If the temperature is too low, it would make the employees feel cold and uncomfortable, the same with the higher temperature, but the difference is that they will feel hot and become sweaty. Air distribution. Air conditioning system requires the people to wait for the temperature in the building to become cooler because of the large space and ceiling. Few air conditioning system may also cause to lessen their air distribution around the building and may also decrease or increase the temperature depending on the season. And lastly, expensive energy bills. A large warehouses takes a lot of energy whether heat or cool. It also reported that HVAC accounts for about 30% total cost of energy in operating in large warehouse or industrial building. In conclusion, ventilation of warehouses is important not only for maintaining desired air quality but also for the staff working there. and to prevent damage to the products that are stored inside the building. E-commerce supply chain relies heavily on good quality warehouses where products can be shipped or sorted for dispatch and sold for future uses. The staff working in warehouses are mostly blue collar, but the whole distribution system relies heavily on the staff for stowage, retrieval, and packaging of the products, and hence good ventilation of the space is really essential. With the requirements of warehouses set to increase exponentially, the need for more advanced ventilation system will also arise and will further help in making the supply chain more effective. That's all for our report. Thank you for listening.